THHN wire is permitted to be installed in cable trays. According to the 2020 National Electrical Code, Section 318.10, conductors and cables listed for use in cable trays are permitted to be installed directly in cable trays. THHN wire is a type of electrical wire characterized by its nylon insulation and widespread use for general-purpose wiring applications in both residential and commercial buildings. It has a temperature rating of up to 90 degrees Celsius, which is equivalent to 194 degrees Fahrenheit, and is suitable for deployment in both dry and wet locations. When undertaking the installation of THHN wire in cable trays, it is of paramount importance to adhere to the manufacturer's instructions meticulously, and to also comply with the requirements outlined in the National Electrical Code. This encompasses employing the correct cable tray fill ratings, and securing the cables to the tray utilizing cable ties or other approved methods. Let's delve into some additional considerations pertinent to the use of THHN wire in cable trays. Firstly, the ampacity of the cable is subject to derating, and this derating is contingent upon the number of conductors present within the tray, as well as the prevailing ambient temperature conditions. Secondly, it is imperative that the cables are adequately protected from any potential physical damage, which includes, but is not limited to, cuts and abrasions. Thirdly, the cables must be supported in a proper manner, so as to preclude the occurrence of excessive sagging. Fourthly, the installation of the cables must be executed in a way that facilitates proper ventilation and effective heat dissipation. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe and effective installation of electrical systems, including the use of cable trays. Understanding and adhering to these guidelines is crucial for ensuring the safety and reliability of electrical installations. Cable trays are structural systems used to support insulated electrical cables used for power distribution, control, and communication. They are particularly useful in situations where changes to a wiring system are anticipated, since new cables can be installed by laying them in the tray, instead of pulling them through a pipe. Several types of cable trays are available, including ladder trays, ventilated trough trays, solid bottom trays, channel trays, and wire mesh trays. The selection of the appropriate type depends on the specific application and the environmental conditions. When using THHN wire in cable trays, several factors must be considered to ensure compliance with the NEC and to maintain the integrity of the electrical system. These factors include the type of cable tray, the allowable fill, the support spacing, and the ampacity of the conductors. Cable trays must be adequately supported to prevent sagging or damage to the cables. The support spacing should be determined based on the manufacturer's recommendations and the NEC requirements. Generally, support should be placed at intervals not exceeding 5 to 8 feet depending on the type of tray and the load. The allowable fill for a cable tray is the maximum amount of cable that can be installed in the tray without exceeding its structural capacity or compromising the ventilation of the cables. The NEC provides specific guidelines for determining the allowable fill based on the type of cable tray, the size and type of conductors, and the number of conductors in the tray. It is crucial to follow these guidelines to prevent overheating and ensure the safe operation of the electrical system. The ampacity of a conductor is its current carrying capacity, which is determined by the size and type of the conductor, its insulation rating, and the ambient temperature. When installing THHN wire in cable trays, the ampacity of the conductors must be derated to account for the increased ambient temperature within the tray and the proximity of other conductors. The NEC provides tables and formulas for determining the appropriate derating factors. For example, NEC Table 310.15 B3 provides adjustment factors for more than 3 current carrying conductors in a raceway or cable. If the number of current carrying conductors in the cable tray exceeds 3, the ampacity of each conductor must be reduced according to the adjustment factors in this table. Similarly, NEC Table 310.15 B2 provides ambient temperature correction factors for conductors. If the ambient temperature exceeds 30 degrees Celsius, the ampacity of the conductors must be reduced according to the correction factors in this table. In addition to derating for the number of conductors and the ambient temperature, It may also be necessary to derate for voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. When installing THHN wire and cable trays, it is important to select conductors that are large enough to minimize voltage drop. In summary, when installing THHN wire and cable trays, it is important to follow the manufacturer's instructions and the requirements of the National Electrical Code. This includes using the proper cable tray fill ratings, securing the cables to the tray, derating the ampacity of the cables, protecting the cables from physical damage, supporting the cables properly, and ensuring proper ventilation and heat dissipation. By following these guidelines, you can ensure the safe and reliable operation of the electrical system. Furthermore, consider the specific environment where the cable tray is installed. If the environment is corrosive or contains hazardous materials, the cable tray and the THHN wire must be suitable for those conditions. For example, stainless steel or fiberglass cable trays may be required in corrosive environments. Additionally, THHN wire with a special insulation rating may be necessary if exposed to certain chemicals or solvents. Proper grounding of the cable tray system is also essential for safety. The cable tray should be grounded according to the requirements of the NEC to provide a low impedance path for fault current. This helps to protect personnel and equipment from electrical shock and damage. The grounding conductor should be sized appropriately for the fault current level and should be connected to the cable tray at regular intervals. When installing THHN wire and cable trays, it is important to ensure that the cables are properly identified and labeled. This helps to facilitate maintenance and troubleshooting in the future. Each cable should be clearly marked with its voltage, current rating, and circuit designation. The labeling should be durable and resistant to fading or damage. Regular inspections and maintenance of cable tray systems are necessary to ensure their continued safe and reliable operation. Inspections should be performed at least annually or more frequently in harsh environments. The inspection should include a visual examination of the cable tray, the cables, and the supports. Any damage or deterioration should be repaired promptly. Maintenance activities may include tightening loose connections, cleaning the cable tray, and replacing damaged cables. Proper documentation of the cable tray system is also important for long-term maintenance and troubleshooting. The documentation should include drawings showing the layout of the cable tray, the types and sizes of cables installed, and the grounding connections. It should also include a record of all inspections and maintenance activities. In addition to the NEC requirements, local codes and regulations may also apply to the installation of THHN wire in cable trays. It is important to check with the local authorities to ensure compliance with all applicable codes and regulations. These local requirements may vary depending on the jurisdiction and the specific application. Careful planning and design are essential for a successful cable tray installation. The design should consider the present and future needs of the electrical system, the environmental conditions, and the applicable codes and regulations. The design should also include detailed drawings and specifications for the cable tray, the cables, and the supports. Proper installation techniques are crucial for ensuring the safe and reliable operation of the cable tray system. Installers should be properly trained and qualified to perform the work. They should follow the manufacturer's instructions and the requirements of the NEC. They should also use appropriate tools and equipment and take necessary safety precautions. Consideration should be given to the routing of the cable tray to avoid obstructions and to minimize the length of the cable runs. Sharp bends and tight radii should be avoided to prevent damage to the cables. The cable tray should be installed in a neat and orderly manner to facilitate maintenance and troubleshooting. Fire stopping is an important consideration when cable trays penetrate fire-rated walls or floors. Fire stopping material should be used to seal the openings around the cable tray to prevent the spread of fire and smoke. The fire stopping material should be listed and approved for the specific application. Surge protection may be necessary to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Surge protective devices or SPDs, should be installed at the service entrance and the critical equipment locations. The SPD should be properly sized and installed according to the manufacturer's instructions. In addition to THHN wire, other types of conductors and cables may be used in cable trays, depending on the application. These may include XHHW, use, and MC cable. Each type of conductor or cable has its own specific properties and requirements. It is important to select the appropriate type for the application and to follow the manufacturer's instructions and the requirements of the NEC. Proper cable management is essential for maintaining a neat and orderly cable tray system. Cables should be bundled and secured to the cable tray using cable ties or other approved methods. The cable should be arranged in a way that facilitates ventilation and prevents overheating. Slack should be provided in the cables to allow for expansion and contraction due to temperature changes. Expansion joints may be necessary in long cable tray runs to accommodate thermal expansion and contraction. The expansion joint should be installed according to the manufacturer's instructions and should be properly grounded. Lightning protection may be necessary for cable tray systems installed outdoors or in areas subject to lightning strikes. Lightning rods should be installed above the cable tray to intercept lightning strikes and divert the current to ground. The lightning protection system should be designed and installed according to the requirements of NFPA 780 standard for the installation of lightning protection systems. Vibration isolation may be necessary for cable tray systems installed in areas subject to vibration. Vibration isolator should be installed between the cable tray and the supports to reduce the transmission of vibration to the cables. The vibration isolator should be properly sized and installed according to the manufacturer's instructions. Chemical resistance is an important consideration when cable trays are installed in areas where they may be exposed to chemicals or solvents. The cable tray and the cables should be made of materials that are resistant to the chemicals or solvents present in the environment. Special coatings or finishes may be necessary to protect the cable tray from corrosion. Ultraviolet or UV protection may be necessary for cable tray systems installed outdoors or in areas exposed to sunlight. UV-resistant material should be used for the cable tray and the cables to prevent degradation and premature failure. Special UV-resistant coatings or wraps may also be used. Accessibility is an important consideration when designing and installing cable tray systems. The cable tray should be located in an area that is easily accessible for maintenance and inspection. Sufficient clearance should be provided around the cable tray to allow for safe working conditions. Security may be a concern for cable tray systems installed in public areas or in areas where unauthorized access is possible. Security measures may include physical barriers, such as fences or walls, and electronic surveillance systems, such as cameras and alarms. Training is essential for personnel who are involved in the design, installation, inspection, and maintenance of cable tray systems. Training should cover the applicable codes and standards, proper installation techniques, and safety precautions. Personnel should be certified or qualified to perform the work. Continuous improvement is important for maintaining a safe and reliable cable tray system. The system should be regularly reviewed and updated to incorporate new technologies, best practices, and lessons learned from past experiences. Feedback should be solicited from personnel who work with the system to identify areas for improvement. Life cycle cost analysis should be performed to evaluate the long-term costs of the cable tray system. The analysis should consider the initial costs, the operating costs, the maintenance costs, and the replacement costs. The goal is to select a system that provides the lowest life cycle cost while meeting the performance requirement. Sustainability is an increasingly important consideration for cable tray systems. Sustainable practices may include using recycled materials, reducing energy consumption, and minimizing waste. The goal is to design and install a system that is environmentally responsible and minimizes its impact on the planet. Global harmonization of standards is an ongoing effort to align cable tray standards and practices around the world. Harmonization can reduce trade barriers, improve safety, and promote innovation. The International Electrotechnical Commission, or IEC, is a leading organization in the development of international standards for electrical equipment and systems. Collaboration is essential for ensuring the success of cable tray projects. Collaboration should involve all stakeholders, including the owner, the designer, the installer, the inspector, and the supplier. Effective communication and coordination are essential for resolving issues and keeping the project on track. Innovation is driving the development of new and improved cable tray systems. These innovations may include new materials, new designs, and new installation techniques. The goal is to develop systems that are more efficient, more reliable, and more cost-effective. Standardization is important for ensuring the interoperability of cable tray systems. Standardized components and interfaces can simplify design, installation, and maintenance. Standards also promote competition and reduce costs. Research and development are essential for advancing the state-of-the-art in cable tray technology. Research should focus on developing new materials, new designs, and new installation techniques. The results of research should be disseminated to the industry through publications, presentations, and training programs. Education is essential for ensuring that personnel have the knowledge and skills necessary to work safely and effectively with cable tray systems. Education programs should cover the applicable codes and standards, proper installation techniques, and safety precautions. The program should be tailored to the specific needs of the target audience. Advocacy is important for promoting the use of safe and reliable cable tray systems. Advocacy efforts should focus on educating policymakers, regulators, and the public about the benefits of cable tray systems and the importance of following applicable codes and standards. International cooperation is essential for addressing global challenges related to cable tray systems such as climate change, energy security, and resource scarcity. International cooperation can facilitate the sharing of knowledge, the development of common standards, and the implementation of best practices. The future of cable tray systems is bright. As technology advances and the demand for electrical power continues to grow, cable tray systems will play an increasingly important role in supporting the safe and reliable distribution of electricity. By embracing innovation, collaboration, and standardization, we can ensure that cable tray systems continue to meet the evolving needs of society. One should verify that the THHN wire is specifically marked or listed for use in cable trays, as this confirms its suitability and compliance with relevant standards.